Hello guys, welcome back to Math Zone African Motives, still on our mathematics for grade 11, that is working with the exponents and surds. This is revision that you're going to work with from our question papers so that we can see how do they ask these typical questions as we are revising towards our exams, whatever practice that you're going to have even in class. All right, that's question 2, where we are given the first part of our question, that was 2.1, to simplify without the use of a calculator, meaning to say the calculator is not required, and these are surds. So there we are referring to surds. Remember, when you are adding or subtracting surds like what we are given here, this is 2.1. We have got 3 square root of 12 minus the square root of 75 like this. Remember that you are supposed to have your answers in simplest form, all right? You are supposed to determine these in simplest form. And whatever that you can add or subtract must be on a condition that the numbers under the square root are the same. If we are given 3 square root of x, that provided that these terms under the square root are the same. So if we check, we've got a 12 and a 75. These two are not the same, and they are also not in simplest form. All right, so this is just a proof that I'm going to show you on the calculator. Then what you do is that you're supposed to know how to proceed with your calculations, but you can just have your calculator as an assistance to know what your answers are supposed to be. The square root of 12, this one, you can simplify square root of 12 like this. All right, you get what? 2 square root of 3. The same thing, the square root of 75 here, you can simplify it, you get 5 square root of 3. But how can we simplify this without a calculator? Because the calculator can just be there as a proof. All right, so this is the case. We need the perfect squares, the highest perfect square or the biggest perfect number that we have in 12, that we can multiply another term or another number to obtain the same number, which is 12. The perfect square, the number must be a perfect square. All right, perfect squares, we're talking about 1, all right? But we can't use 1. Yes, this 1 is a perfect square, but in our simplification, we can't use 1, all right? So we're talking about 4, all right? 3 squared, which is 9, 5 squared, which is 25, 6 squared, 36, 7 squared, 49. These are the perfect squares. So we have to check for this highest perfect square that we can obtain in what? In 12. And in that case, we can see that this is the same as 4 times 3, right? 12 is same as 4 times 3. That's if we use 4 and 3. 4 times 3, it gives us what? A 12. All right, minus the square root of 75 in terms of a perfect square. We can't use 4, we can't use 9. Which number that we can use? 9 times which number that gives, of which we do not have, right? We move on to 25. 25 times 3, it gives us a 75. So that is, we're going to have 25 times 3. Why writing in terms of perfect squares? Because we understand that from our laws of surds, the square root of AB like this is the same as the square root of A times the square root of B, separated from the single square root that we had. Now it's the square root of A separate, the square root of B separate. So meaning to say, if two numbers are under the square root like this, they can be separated as the square root of 4 times the square root of 3. We have, or we can obtain this. That's why we have to choose a perfect square so that we can determine its square root. What is the square root of 4? The square root of 4 is 2, right? That's 2 times 2, which gives us what? Which gives us a 4, of which you can even use a calculator there. All right, no one is going to know that you have used a calculator to determine this. So the square root of 4 is 2. Then we've got the square root of 3, which we can't determine. So it's going to remain as 2 square root of 3. So this is what we're obtaining from this. We are obtaining what? 2 square root of 3. But take note, already there is this number 3. So it's going to be 3 times the answer that we obtained here, which is what? 2 square root of 3. Minus, we do the same thing on this. 25 times 3. It is the same under the square root as the square root of 25 times the square root of 3, separated square root of A times square root of B. We know the square root of 25, the number that we multiply, that multiplies itself to give us 25 is what? 5. but we do not know the square root of 3. So the square root of 3 is going to remain under the square root. So here we are just going to have 5 square root of 3. We do not have the number. The number is just a 1. So it means if you multiply by 1, it's just going to remain like that. So we can simplify 3 times 2. The numbers under the square root can multiply each other. That's 6 square root of what? Square root of 3. So this is going to be 6 square root of 3 minus 5 square root of 3. So this is the idea that I was talking about. As long the numbers under the square root are the same, we can perform our subtraction. It was impossible in the first place because of the numbers that were under the square root. There were different numbers there. But as we have now that these two numbers that we are having, they are the same. The square root of 3, the square root of 3 are the same. So what do? We simply subtract the numbers here. 6 minus 5, which is 1. So that's 1 square root of 3, which is same as what? Which is same as the square root of 3. So that is how we could have simplified this. So these are the typical questions of which we can prove this on our calculator. Like I said, the calculator is not required, but you can also prove that on your calculator to see if we obtain the square root of 3. That's 3 square root of 12 like this minus the square root of 75. All right. Sorry for that. So just going to move aside like this. Right. We need to remove this negative first, then move aside, put minus the square root of what? Of 75. That is going to give us the square root of 3, which is the same answer as what we got previously. All right, so these are the typical questions that you might expect to have. All right, 2.2, we are now given without the use of a calculator again, show that this here is equivalent to this. It is equal to this. All right, let's see, 2.21. They are saying 2 to the exponent of 2010. All right, plus 2 to the exponent of 2012 is this case is equal to 5 times 2 to the exponent of 2010. All right, we are asked to show, meaning to say we have the answer already. The answer is there. Our answer is supposed to be like this. So meaning to say we have a side to choose, either from here to this, but it's either we're going to have here to this or the other way. So as for us, we're going to try to work from the left-hand side where we have the most complicated part of our equation. All right, so from the left-hand side, we can see that we are given 2 to the exponent of 2010. That's 2 to the exponent of 2010 plus 2 to the exponent of 2012. How do we simplify this so that it gives us the same part as this, what we have here? All right, let us check this. On our final answer, we can see that there is a 2 to the exponent of 2010, meaning to say that I tried by all means to remain with what? 2 to the exponent of 2010. We can see that is still there on our final answer, but this is no longer there. So meaning to say we can try by all means to write this as 2 to the exponent of 2010, which is the 2 to the exponent of 2012. This one, there's no need for us to simplify this because we can see it's still there on our answer. So we are supposed to think on this one. How can we write this in terms of the same 2 to the exponent of 2010? All right, let us get back to our exponents from our laws of exponents. We know that if we are multiplying a to the exponent of m times a to the exponent of n, we have the power to add the exponents. That is the law number 1. If we are multiplying the bases that are the same, we can add the exponents. So meaning to say, if we can maintain the base of 2, if we can maintain this base of 2, we can say this is the same as 2 to the x. We want to remain with what? To the exponent of 2010 must remain. So if we have 2 to the exponent of 2010, we are going to multiply it to what? So that we obtain the same 2 to the exponent of 2012. Since we are supposed to add, to know the term that we are going to use here, we simply subtract 2012 minus 2010. If we subtract this, we are going to obtain a difference of 2. So that means if we multiply to 2 to the exponent of 2, we are going to get 2 to the exponent of 2012 because we're going to add the exponents. Since we are multiplying the bases that are the same, we add our exponents. That's 2010 plus a 2, which is going to give us 2012. So it means in place of this 2 to the exponent of 2012 that we are seeing here, We can substitute with the equivalent, which is this part. We can substitute this with what? 2 to the exponent of 2010. That's 2 to the exponent of 2010 times 2 to the exponent of 2. Remember, our major issue here is to have this situation here. All right, let us try to have this. Very sorry for that. Very sorry for that, guys. I want this one. Our major aim is this one, to have this. 2 to the exponent of 2010, 2 to the exponent of what? Of 2010, which is common throughout. This is our common term. So what are we going to do? We are going to factor it out. This is same as we are multiplying by 1. So if we factor out 2 to the exponent of 2010, which is the one that is common here, what are we going to remain with here? We divide, so you're going to remain with a 1, plus if we divide by 2 to the exponent of 2010, we remain with what? 2 to the exponent of 2. So this is what you're going to have at the end. 2 to the exponent of 2010 times 2 to the exponent of 2, that's 4 plus 1, which is 5. So as we can see, this is the same answer as what we are having here, only that they just started by 5. Remember that A times B is the same as B times A. So if we are multiplying this times this, it is the same as we are multiplying 5 times 2 to the exponent of what? Of 2010. That is the same situation that we're having there, which is exactly what we are having on the what? On the right-hand side. So we have actually proved this. So to prove on this scenario, you have to check what you are having on the what? On the final answer. How is it written? And how can you write the same in the same way that you're given on the final answer here? There is no way we can simplify the first 2010 here, 2 to the exponent of 2010, because it is the same as what we have here. We already have that. So there's no need for us to simplify this. We have to think around here to say, how can we have this in the same way as 2 to the exponent of what? Of 2010. So we must expand it in terms of 2 terms. But having the base of what? The base of 2, that is the most important thing. All right. So we just have to revise as much as we can. Then our factorization also is very, very important. Then this is a continuation here. Hence, calculate the value of. All right. So if we check here, I want us to see something. All right. This is the one that they want us to calculate. All right. Let us have our question first. I want us to see something there. Let us just rewrite our question. They are saying, hence, it's a continuation. So meaning to say from what we already have. So this is 2.22. We are asked to simplify 2 to the exponent of 2010 plus 2 to the exponent of 2012. All right. So this is plus 10 like this. Everything over. That was 2 to the exponent of 2009 plus a 1. All right. That is the one that we have here. So hence it's from what you have just calculated. What have we calculated? We have calculated this part. We have simplified this. 2 to the exponent of 2010 plus what? 2 to the exponent of 2012. This is what we have simplified, and we said it is equal to this. We proved that. All right. I want you to check something here. I want you to see something. If we check properly, there on the question that we are supposed to answer, this one, there is a 2 to the exponent of 2010 plus 2 to the exponent of 2012, this one, which is the same as the 2 to the exponent of 2010 plus 2 to the exponent of 2012, this one. That we simplified before, and we got what? We got this as our answer. So it means as a hand, we can rewrite this the same, because this here is the one that reduced to this. So you're going to take that 5 times what? 2 to the exponent of 2010 plus a 10, everything over 2 to the exponent of 2009 plus a 1. That is the part of the hands. We have used that part of the hands. Hence, it's a continuation from what you have determined. Continue from there. Continue from what you have just determined. But in place of what? Of exactly the same expression, this one. So we have used that. But after now that we have substituted, we have seen that, okay, this is the same. We have substituted this. What are we going to do? The nth part, we have used it. So the rest now is up to you guys. How are you going to simplify this? Okay, if we check now, we can see that, remember, we've got here a 2 to the exponent of 2010. And we've got a 2 to the exponent of 2009. So in cases like this, where you are simplifying, this time you're not given the answer to prove. So how do you simplify these questions? You target the one that has got the smaller exponent, 2 to the exponent of 2009. The one with what? The smaller exponent. That is the one that you target. What am I trying to say? Just like what we saw here, we saw that we had a 2 to the exponent of 2012. They wrote the answer in terms of 2 to the exponent of 20. That was the smaller number. If you compare 2010 and 2012, 2010 is smaller. So if you check, your answer is written in terms of the smaller one. This is because that is your highest common factor. The highest common factor is the common term that carries, or that has got what? The smallest exponent. So you take the one with the smaller exponent. Take note about that. So meaning to say, I'm supposed to write this in terms of this one, which is the smaller exponent. So how can I write 2 to the exponent of 2010 as a number which is 2 to the exponent of 2009? How can I write it like this? It means we are going to multiply this by 2 to the exponent of what? So that we get the same 2 to the exponent of 2010. Remember, we said if the bases are the same, we are going to add the exponent. So it must be to the exponent of 1. 2009 plus a 1, it gives us what? It gives us 2010. Okay, guys, please be careful there. We want to have this in terms of the smaller exponent, which is 2 to the exponent of what? 2009, this one. So that's why we have to expand targeting this first. So we now have the equivalent, this one. So it means we're going to have 5 times 2 to the exponent. In place of 2 to the exponent of 2010, we're going to substitute this equivalent, which is 2 to the exponent of 2009 times 2 to the exponent of 1 plus a 10, which is this one that we are already having. All right, everything over what? This part is already in the simplest form because that is the smaller exponent. So there is no need for us to rewrite this. We just have to remain with this as it is, to the exponent of 2009 plus a 1. So you're going to see what is going to happen here. All right, if we check properly, these two numbers can be simplified together. We can multiply 5 times 2 to the exponent of what? Of 1, which is simply a 10. 5 times 2, that's a 1. So meaning to say we have a 10. So that's 10 times 2 to the exponent of 2009 plus a 10. So this 10 came from multiplying these two numbers. These are the numbers that gave us what? A 10. Remember, we are supposed to see this. So we are not supposed to simplify anything from there. All right, this here is over. All right, so this is going to be over our denominator here. That is 2 to the exponent of 2009 plus a 1. What are we seeing that we can do? We can see that on the numerator here, there's something common, 10 and 10. So by our factorization, we can factor out this 10, a common term. So if we factor out this 10, what do we remain with? If we divide here by 10, we are going to remain by what? 2 to the exponent of 2009. Plus, if we divide by 10 here, 10 divided by 10, we get what? We're going to get a 1. So meaning to say here, we are going to get a 1. Everything over what? There's nothing common here. So we're just going to write as it is. 2 to the exponent of 2009 plus a 1 as it is. So as we can see that these two are actually the same. The one that we have this bracket on the numerator, this part as it is, this is like we have got a bracket. It's like we've got a bracket and a 1 here. It's just one is the same. So you can see that this bracket is the same. This and this can cancel. We remain with 10 over 1, and 10 over 1 is same as what? Is same as a 10. So that is how we could have simplified our question. So we have to be very, very careful with the use of our laws. How do we apply our laws is very, very important in our simplification, and also to consider your factorization in any simplification that you have. All right, let us check another part of our question. Like I said, this one, it was a hence. So it was a continuation from what we had. All right, this is question 2.3. Simplify this here. We are given that is a 2.31. So we asked you to simplify x to the exponent of -1 plus y to the exponent of -1. Remember, from our laws of exponents, to the exponent of -1 is the inverse, that is 1 over x, the reciprocal of x, plus the reciprocal of y, which is 1 over y. So here, guys, we can simply add, as we understand from our fractions, from our grade 10, that we determine the LCD of the given denominators x and y, which is what? Xy. Then we divide, that is our LCD to this denominator x. If we divide xy by x, here what's going to happen? This and this cancels. We remain with y. So that's y times the numerator, y times 1, which is y, plus the same thing, our denominator divided to y. Y is going to cancel. That's xy divided by y. This cancels. You remain with x. That x, you multiply it to 1. So x times 1 is what? It's x. So that is what you're going to get. Just like that. Which is y plus x over y, which is, we can even write as x plus y like this over xy. It's just in one and the same thing. Remember, a plus b is same as b plus a. All right. So that is how we can simply write it like that. All right, then 2.32, hence again, just like the previous case, hence, like I said, it's a continuation. From what you have determined, this is what you have just obtained. Continue from there. They are saying now, determine the sum of the reciprocals of the two variables if their sum is equal to 10 and their product is equal to 20. They're saying determine the sum of the reciprocals, guys. The sum, remember, these are our reciprocals, like I was saying before. These are our reciprocals. So meaning to say we are just having a continuation here. We added together our reciprocals. This is what we got. All right? We got x plus y. This is just a continuation over xy. So the sum of the reciprocals, these reciprocals, 1 over y plus 1 over x plus 1 over y. And they're saying the sum is equal to what? To 10. The sum x plus y is 10. And the product is what? Is 20. The product of these two is what? Is 20. So this question was not properly given, but that is what they were trying to say. They were supposed to talk about x. The product is not of the reciprocals. The product is of x and y. All right, so take note. So that is going to give us a 1 over 2. If we divide by 10, that's 1 over 2. All right, so that is what you were supposed to have in this case. So guys, be very, very careful in your simplification. You are ought to understand how your questions are given and how do you simplify those typical questions in your exam. But for now, that's it, guys, from Maison African Motives. Till we meet again.